In this video, we'll cover the solutions to lab 5.5 and 5.6. Really, it looks like we're going to solve proportions here. Right? We have 1 over x squared minus 8 on the left side of the equal sign and 1 on the right. We could solve this in two ways. One, we could graph both sides of the equal sign. Right? So I could graph y1 as 1 over x squared minus 8 and y2 is 1, and the intersection would give me my answer. Okay, but another way to solve this would be simply to just cross multiply, right? So instead of writing 1, I like to write 1 over 1, so it looks like I have a fraction on both sides of the equal sign. And remember, 1 divided by 1 is the same as simply 1. So I'm going to do 1 times 1 equals 1 times x squared minus 8. Solve for x. So you have 1 equals x squared minus 8. If I subtract 1 from both sides, we have 0 equals x squared minus 9. This becomes a difference of 2 squares, right? X plus 3x minus 3. So the solution, what value of x makes this 0, would be positive 3 and negative 3. So if I were to put a 3 in for x, square it, and subtract 8, I'm going to end up with 1. If I put a negative 3 for x squared, or negative 3 for x and square it, I'm going to end up with the answer of 1. Right? So the solution to this equation, what values of x would give me 1, would be negative 3 and x. For question 2, same thing. We're going to cross multiply. So I'm going to write 3 times 2x minus 7. It's important to put this in parentheses because we're going to distribute the 3. And then 5 times x plus 1, again, in parentheses. So we distribute the 5. And then we simplify, we solve for x. So the value of x that would give me 5 over 3 is 26. Again, you could graph both sides of the equal sign, and you're going to end up with an intersection that happens at x equals 26. Question 3. All right, well, we can't cross multiply yet, but we can write 3x minus 4 all over x minus 1, because we have the same denominator. Then cross multiply, right? X minus 1 times 6. Equals 3x minus 4 times 1, right? Once we combine 3x minus 4, we can cross multiply with the 1 and the 6 with the x minus 1. All right, we simplify, we end up with x equals 2/3. Now for some application problems, okay? We have looks like a cost function for the number of lawnmowers. We're trying to figure out the average cost for lawnmowers, where x is the number of lawnmowers produced. So it says we want to figure out how many lawnmowers we need to produce to get an average cost of $250.50. So replace the C, right, the average cost, with the $250 and solve for x, which is the number of lawnmowers. Again, I would simply cross multiply and solve for x just using algebra. Right? So I have to produce 635 lawnmowers to get an average cost of $250. Question 5. All right, so we have a drug that goes into a bloodstream. Again, we could graph both sides of the equal sign, right? The 0.5 is what we're going to enter here. We could graph both sides of the equal sign and get the intersection. But an easier way would be simply to cross multiply. Right? Put the 0.5 over 1 and cross multiply with the 14t over 3t squared plus 2.5. And when we get down to here, we can't really solve this easily. Again, we could graph both sides of the equal sign or use the quadratic formula. And you notice we have two answers. Some people would say, okay, so the concentration is 0.5 at 0.09 seconds and 9.24 seconds. I know some people discard this answer, while some professors would argue, okay, when I put a needle into your arm, and I start squeezing the needle, it might take a little bit of time. You start out with 0 milligrams per liter, and then eventually it's going to increase to the maximum dosage, and then eventually dissipate. So perhaps you're going to have 0.5 milligrams per liter at 0.09. And actually, this says seconds. This should really read time. There's an error on this lab, right? Because remember, it says t is the number of minutes after the injection. So t should be 0.09 minutes and 9.24 minutes, not seconds, okay? Question 6, all right, so we have this bird. it flies up and actually drops the mussel to crack open the mussel to get the meat inside the shell. Okay, so this function gives you the average number of drops per height, right? So I assume if they went to a certain height, really high, they probably have to drop it once to crack it open. But we want to know how high is it if the average number of drops is 2. Right, so the bird's going to fly up, it will drop the mussel. If the mussel doesn't open, it will actually pick the mussel up again and go higher and drop the mussel. So to solve that, we replace the f with the 2 and then cross multiply. When we cross multiply and simplify, we end up with 55.7. So this bird's going to go 55.7 feet in the air and drop the mussel. The first drop probably doesn't crack. So it goes back to this height and drops it again, and the second drop does the trick, and the bird gets the meat inside the mussel. That's it. That's all I wanted you to get out of section 5.5, 5.6. Thank you for watching.